Okay, so we're recording the session. Thanks for stopping by. This is the first session for week 4. I'm going to share my screen, so let me know if you can see my screen here. Okay, so if you can see my screen, just say yes. Okay, great. Alrighty, so let me just go over a few things real quick. So I just want to make sure you guys are aware that you can click on this once you're in your course shell in Blackboard. You can click on this STEM Learning Community and then look for Math 130 and 240 link here. So click on that, and then you can click on this um, book a tutor and book now. And so you can essentially, if you're looking for tutoring help, this is the way to do it. But I also want to remind you that your best resource in the class, is your instructor. So if you have any questions, please reach out to your instructor, and they will be more than willing to help you um, with any questions you have, or if you just want someone to explain the concept. Um, the other thing I want to show you is in MyStatLab, if you click on chapter contents here, well, it wants me to leave this, that's okay. So if you just click on chapter contents, what you'll see is this is the electronic version of the textbook. Okay, so these are all the chapters, the different chapters in the textbook. You can click on them and click on each of the section, and then you can watch the videos in it, or you know go to the e-text. E-text is essentially the you know the the actual textbook. So you can just click on e-text and it'll open up the textbook. So I just want to make sure you're aware that you have access to the electronic textbook. If you have, I mean, I'm sure you all have access to MyStatLab, so you don't have to buy the uh, the hard textbook. It's there. Okay. All right. So let's go to the homework. Now tonight we're going to talk about confidence interval. Hypothesis testing. It's a little bit different than last week, but the concept is very much the same. Okay, there are questions. I suppose I can show you that. So if you go to your course shell and there's an option called webinar information. So if you click on this, and then if you scroll down, you'll see the course calendar here. And in the course calendar, you'll see, our um, the schedule for the webinar, schedule for webinars, and it looks like I need to update the next week's webinar from Thursday to Wednesday. But anyway, you'll see the schedule for webinars, and you'll also see the webinar recording links that I post every time the webinar is over. I post the link there. So just make sure to access the link here. Or as I mentioned earlier, you can just use Professor David's website. I also update this website to put the links there. So there are two places to get the links from. Okay, so I'm going to talk about some reason I want to talk about confidence intervals tonight, but we're going to talk about hypothesis testing. So let me ask you a question. This is something that we ask ourselves almost every day without knowing. So and this this is one of the main reasons why um, we would want to do analysis using statistics is because we make claims, and then what we want to do is we want to use the data to see if the claim is statistically significant. And if it's not, then we want to say it's not. Okay. So, for example, you know, someone could, someone could say that, say, in the year 2005, which is now 10 years back, right? Year 2005, say someone had, done a study and found that 20%, okay, I'm just going to use a number, 20% of adults who bought a car preferred, say, a specific brand. Okay, so I'll just say Chevy. Okay, this is just, I'm just, this is not real data. Okay, it's just a claim. Okay, so in year 2005, there was a study done by someone, and in that study, they found that 20% of adults who bought a car preferred Chevy. Okay, the brand Chevy. Now, now we are in 20, almost 17, right? But let's say we're in 2016. Okay, and so it's been 11 years. And so the question now is this claim still valid? Okay, so it's been 11 years, and in 11 years, a lot of things can happen, right? Behaviors can change. A certain car brand can have issues over the years, which will drive consumers away from them. Okay. Yes, newer models of the cars. Maybe a new car brand comes that just takes a lot of interest. So a lot of things can happen. So the question then is this claim still valid? So how do we test it? Well, let's take a look at the original claim again. We said 20% of adults preferred Chevy. And so what we can say then is today, so now we're in 2016, okay? In 2016, we can do what we call a hypothesis test, okay? Hypothesis test. And in the hypothesis test, we can call null hypothesis. I mean, I'm sure you all know what a hypothesis is, right? But this is something new. Null. What does null hypothesis mean? Null hypothesis essentially means that whatever claim that was made in the past originally is still true. Okay. So for example, in this case, by the way, in this claim, are we making a claim about the population proportion or population mean? So what are we making the claim about? Is it the mean or is it the proportion? It's the proportion. Very good, because I'm using percentage here, right? So in this study, the null hypothesis will be that today the P population proportion is still 20% or 0.20. Okay. Now note, I'm not using P hat, not the sample proportion. The claim is being made about the population, right? People, for example, and by the way, I should say US adults. Okay. So just we're only considering um, the population of the United States. Okay. Who bought a car. So then this proportion is the population proportion. Okay, the claim is being made about the population proportion. Okay, so the null hypothesis says that population proportion, you know, uh, the U.S. adults who bought a car, preferred Chevy is still 20%. Okay, and then the alternative hypothesis So now we are considering what happens if this is not true. So say we analyze our data and we find that this is not true. Well, then what else is true, right? What is true? Well, then obviously what that means is we need to have something other than the null hypothesis. And what we need is what we call alternative hypothesis. Alternative is if the null is not true, then the alternative, is going to be true. Okay. So, so just like Sandra says, one of them can be p is not equal to 0.20. Okay. So we can say that the proportion is not equal to 20%. It's something else. It could be 40, it could be 10, it could be something else, but it's statistically different than p equals 20%. Okay. But we can also have what if, for example, this brand has produced some really nice cars over the years and has some really nice options so that the proportion has gone up. Okay. So there are more people preferring this brand. Okay. So in that case, the alternative could also be that is greater than 20%. Okay. So maybe we'll find that the data that we've collected is showing us that the proportion of adults who prefer Chevy now is more than 20%. So in that case, the alternative hypothesis will be that P is greater than 20%. Now, a lot of the problems will tell you this, but will tell you what the alternative hypothesis should be, but you will be required to sort of know how to select the right alternative hypothesis, and this will come as practice. As we practice, you'll understand what that means. Okay. And then obviously, if the brand has gone through some really tough times, then that proportion can drop, and maybe the alternative can also be 0.20, right? Less than 20%. So there are three options here, and we'll have to always pick one. You cannot have all three at the same time. You can't have two at the same time. You have to pick one of these, okay? And this will come as practice, or the question will tell you what it is. Okay, now what I want to mention here is this hypothesis test will rely on either the z or the t distribution. So we'll always draw this out, and I'll show you how. But it will always be a bell-shaped curve, and it will always be based on the bell-shaped curve. Now, if the alternative hypothesis is chosen to be not equal, then we will have what we call a two-tailed test. And what that means, the two tails, you can guess by this sign here, not equal sign. It means you can be much more than 20% or much less than 20%. And in that case, your tails are going to be on the extreme right and the extreme left side of the distribution. Okay. And what this signifies is this is what I'm going to call this the rejection region. Okay. When we analyze our data and say that we find that our value that we calculate, the z value that we calculate, falls in this rejection region. And actually, I should highlight it using the red, because red will mean that, oh, this is a bad sign. Well, maybe it's not a bad sign, but what it is it's a significant sign that you should do something. That the claim maybe is now not true. The null is not true, right? So what this means is this will be the rejection region. This is the region if your z falls into this region, you will reject the null hypothesis in favor of the alternative hypothesis. Okay, so you will say, oops, I'm way further in this rejection region, and so the null is not true. Okay, and again, this will come as practice. But the key thing is that this not equal is going to be a two-tailed test like this. The tails will be on the right and the left side. Okay, and then similarly, in this case, what do you think will happen in this case? In the case where P is greater than 20%, where do you think the rejection region will be? Will it be on the right side or the left side? But very good, Brian, and everyone else, very good. It is going to be on the right side. Okay. So A nice hint here is that think of this greater sign as an arrow. So it's pointing to where the tail should be. In this case, it's pointing to the right side, right? It's pointing to the right, so the tail is on the right side of the distribution. And then similarly, the tail can also be on the left side, which is the case here. And let me just draw out. And so the tail is on the left side, and so it's right here, and I highlight this area, and this is it, okay? So this is a two-tailed test. This is a one-tailed test where the tail is on the right side. This is a one-tailed test where the tail is on the left side, okay? One other thing I want to point out, and then we can start off our questions, is that the null hypothesis is always going to be in the center, okay? The value of the null hypothesis is going to be in the center, okay? So you can see if the null value is in the center, then if I'm in this rejection region, I'm way, I'm too far away from the null value, right? Which is why we reject the null value. If we are in this rejection region, right, this distance is going to be, we'll consider this it's far away from the center, so it's far away from the null. Which is why if we fall into this region, we'll say, okay, we can say that statistically we're, much further away from the null hypothesis, in which case we will reject the null hypothesis, okay, in favor of the alternative hypothesis. Okay, now all of this will come to you naturally as we practice these problems. Obviously all of this will not make sense right away, okay? But eventually it will. As we do these problems, it will, okay? Kathy can't hear me, so, oh, I hope you can all hear me. Can you hear me? Okay, so maybe Kathy can. Okay. All right. So can we get started? Does this make a little bit of sense? Why we have the null hypothesis, why we have the alternative hypothesis, and why, how how we have these three options for the alternative hypothesis, and then how they relate to the two-tailed or the one-tailed test. Okay. This is good enough to start the homework assignment. Okay. So here's a problem. A null and alternative hypotheses are given. To determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed, and what parameter is being tested. So what is the parameter that we're testing here? P equals 0.9. What is the parameter? Is it the proportion or is it the mean? Or is it, I should say, is it the population proportion or is it the population mean? Yes, very good. It's the proportion. Now, I would recommend that you should always say that we're testing the population proportion, okay? You don't want to confuse this with the sample proportion because we're not testing the sample proportion. We're testing the population proportion. We use the sample proportion to do the analysis to test the population proportion, okay? Well, because we want to, because Sarah, that's a good question. So the reason for that is because whenever we take samples, right, in statistics, whenever we take a sample to study something, we're not trying to make, we're not trying to like make any judgment about the sample. We want to study the population. And so, but the population is too large, so we can't study the entire population. So we take a small chunk of that population as a sample, we study it, and then we say, okay, we have enough evidence in this sample to make this conclusion about the population. Okay, that's the reason why we test population proportion or population mean under the null and the alternative hypothesis. And then we take a small sample, we take a small chunk of the population, analyze it, and then say, okay, the population proportion, either the null is true or the alternative is true. Okay, that's the reason why we to population. So what is what is the parameter? Population proportion. What kind of a test do we have? So, I mean, the answer is obviously right-tailed. But how do you know it's right-tailed test? Yes, you look at the alternative hypothesis and you see that there's a greater than sign. So we're testing the right-tailed. So it's a right-tailed test. So it's a one-tailed test where the tail is on the right side. So it is this case here. Okay, excellent. All right, second problem. Hope I didn't miss any parts here. No. Okay. Here's the second problem. Determine the null and the alternative hypothesis. And then they're talking about type 1 error and type 2 error, and I'll have to explain to you what that is. But let's just see what it is first. 6 years ago, so you can see here, okay, these are the words to pick your null hypothesis from, okay? Remember I said here, the null hypothesis is always based on the past. You've done some study in the past. You found some results from the past that you're now, testing. Okay, you're testing the claims made in the past. So the null hypothesis almost always comes from, you know, from the past. Okay, from a study that was done in the past. So 6 years ago, 12.6% of registered births were to teenage mothers, and sociologists believe that the percentage has increased since then. Okay, so 6 years ago, this was the finding, but today there's a sociologist that believes the percentage has increased. So my question to you is, first of all, what is the parameter that we're testing here? Yes, but what kind of a parameter are we testing? Are we testing the population proportion or are we testing population mean? Population proportion. Yes. Okay. And looks like Kayla is having technical problems. I'm hoping that no one else is having these screen, uh, having the screen freezing. Okay. Kayla, it might help to log out and log back in. Okay. How do we determine if it's population or mean, proportion or mean? Well, it's proportion because we're considering percentage here, right? So because we're considering a percent sign, so we are talking about proportions. For the mean, you'll see that this will be like an average. They will be talking about an average. Okay, so that's how you tell whether the hypothesis test is on the proportion or the mean. And we'll do some problems for the mean, then you'll be able to identify the difference. Okay, so that's right. So now my question is this a right tail test or a left tail test or a two tail test? It's a right tail test. Can you tell me why it's a right tail test? Why do you think it's a right tail test? Yes, because the sociologist believes that the percentage has increased since this 12.6% sign was, 12.6% proportion was, um, computed. And so because there's an indication that it has increased, so the alternative hypothesis will be that P is greater than 0.126 today. Okay, that's why it is a one-tail test where the tail is on the right side. Okay, very good, everyone. Very good. Okay, now let me tell you what type 1 and type 2 errors are. Okay, so try to follow this, and I'm gonna have you follow with me and then stop me if you don't understand this. So now we know that we have H naught, which is the null hypothesis. Okay, H, we call this H naught, and this is it's just an indicator that indicates that we're talking about a null hypothesis. And the other indicator for alternative hypothesis is H1. You can call this H0 and H1 as well. But this is the alternative hypothesis. Okay. Okay, now, of course, do you all agree with me that sometimes hold on. Let me see what's the best way to draw this out. Let me see. Let's call this your findings. Um, and uh, and I'll maybe call this actual. Okay. I'm not sure what Conrad, what you mean by growth, but um, uh, so you either have a right tail, left tail, or two tails. When the question talks about an increase, okay, in the proportion or the mean, then you have to consider the right tail, okay? If the question talks about a decrease in the proportion or the average, then it's a left tail. If the question talks about that there has been a change, has there been a change, then the change means it could be either right or left. Then we have a two tail, okay? So again, this will come as we practice problems. This is a little bit hard to sort of explain until you actually see it in a problem. So the word to pick here was that the sociologist believes that the percentage has increased. Okay, the word to pick here is increase. And so because there has been an increase, your alternative hypothesis has to show that the P has increased from the null hypothesis. Okay, that's why this is a right tail test because of this greater than sign. Okay, now what will happen is, and let me just make this a little bit nicer so that you can follow. Let me just write this out and then I will explain what I'm doing here. Okay, so consider this now, all right? Consider, whoa, not that, I need black. Consider this matrix, okay? And okay, so this is going to be a little tricky, but try to understand this. Sometimes you'll get problems where in actuality the null hypothesis will be true. Okay, so what that means in that example that we did for the cars, what that means is that still today 20% of the population will prefer the brand Chevy today, even today. Okay, and when you do your analysis, you'll find that yep, null hypothesis is true. Okay, that yes, 20% of the population still prefers the brand. So in actuality, the null hypothesis was true, and your findings also say that the null was true. Okay, so do you all agree with me that we've made a correct decision here? Do you all agree with that? If the actuality is that the null is true, and you also find that the null is true, you've made the right decision, right? So your hypothesis test is correct. I shouldn't say hypothesis test is correct. I should say that your finding is that the null hypothesis is it cannot be rejected. Okay, that it is still true. Okay. Okay. Now the other case is in actuality the null hypothesis is not true. Okay, and you also find that the null hypothesis is not true. Okay, so which will be this box here. So do you all agree that you've again made a right decision? Is that true? Is it right? So you all agree that you've still made a right decision because the null was not true and you found that the null was not true. Your hypothesis test has given you the correct conclusion. Okay? So do you all agree that we should put a green check mark here? No, Rob, the actual means that in reality, okay, that the null hypothesis is true. Okay? Like in reality, the null is true. Like today, even today, 20% of the population prefers Chevy in actuality. Okay? That's what that means. And then you take a sample and you also find that 20% still prefers the brand. Okay? That means your sample analysis has um, concluded that the null hypothesis is true. You didn't know anything about the null hypothesis before you took that sample. Okay? Yes, Vince. So I'm gonna get to that. Yep. So now you've all sort of followed with me here, and we'll put green check marks. But now you also have cases where the null hypothesis is true, but you end up saying that it's false, and this will happen. Okay. So this will happen when the null hypothesis is true, and you end up saying it's false. That is an error. Okay. You've made an error. This will happen because now what you may ask why. Well, that's because the sample that you take from the population to study to get to your findings, that sample, may just have bad data in it. Maybe, you have not taken your sample properly. Okay? Maybe you've landed on, part of the data. Maybe like, for example, you were taking the sample in a specific month when the sales are down, right? So maybe you this can happen due to various reasons. And what I'm trying to say is, if in fact, in reality, null hypothesis should be true, but you end up saying that it's not true, then you've made an error. Okay? And this error here is called type 1 error. And again, this will come to you as we do some problems. This is the concept behind it. Once we do some problems, then you'll understand what it means. Okay? Um, well, Jessica, for example, like in the example I gave, where say that even today, 20% of the consumers prefer Chevy brand, but you take out a sample, say that it's not a good representative sample of the population. So you take out a sample that is biased towards Chevy for some reason. It can happen due to various reasons. Actually, the perfect example for having a sort of like a biased sample, are all these polls that were coming out in this election, right? The polls were saying something else, but something else happened, right? It can happen due to various reasons. So the sample you take out, you find out that, oops, it's not 20, null hypothesis is not true, that 20% of the consumers do not prefer Chevy. Maybe you find out that that is much less, it's 10%, right? Well, in reality, if you were to take many samples, you would still find that the null is true. It's just that you landed on this bad sample and you think that the null hypothesis is false, is not true. Well, it is true and you've made an error. And this is a type 1 error. Okay? And just like this, it could also be the other way. The null may not be true, but you fall on a sample where you end up finding that it is true. And so therefore this box will also have a cross, and this is called a type 2 error. Okay? Now this is something you'll have to remember. When the null hypothesis is true and you reject the null hypothesis, based on your analysis, that's a type 1 error. When the null hypothesis should be false, but you know, based on your analysis of the sample, you find that it's true, then you've made a type 2 error. Okay, so let's take a look at this example now. So in this example, we are saying that 6 years ago, 12.6% of registered births were to teenage mothers. Okay, so this is the null hypothesis. The null hypothesis is that P is equal to 0.126. A sociologist believes that the percentage has increased since then. So the alternative hypothesis is that P is greater than 0.126. So which one of these is a type 1 error? So let me first read out the correct answer. Remember, type 1 error means that the null is true and you reject the null hypothesis. Okay, so take a look at this. The sociologist rejects the hypothesis that the percentage of births to teenage mothers is 12.6% when it is in fact true percentage today. Okay, so if we're saying today, in reality, the null hypothesis is true, okay? And we will not know that, but it is true. And when the sociologist does the analysis, she finds that the null hypothesis should be rejected, okay? So this, obviously she has made an error here, and so the error is type 1 error, okay? Okay, just try to follow this and I'll tell you how do we know from the next after this problem. I'll show you on the null on the normal distribution curve the probabilities associated with type 1 error and type 2 error, and that might help a little bit more. Now, what is the type 2 error? Remember, the type 2 error is when the null hypothesis is actually not true, it's false, but your analysis says that is true. And so the answer here is that sociologist fails to reject the hypothesis that the percentage of birth to teenage mothers is 12.6%. So she's failing to reject the hypothesis, meaning she's essentially she's saying that the null hypothesis is true when the true percentage is greater than 12.6%. Because you see this, if this is not true, then this is going to be true. Okay, so if in fact this is not true and this is true, but your analysis says that, yep, this is true, then you've made this type 2 error. Okay, that's what that means. That's actually, Conrad has a very good example there. Actually, Conrad or anyone else, when towards the end of the session, if you can remind me, I'm going to share a link with you that is exactly the example that Conrad has given, which actually happened. Um, I think it was in the 1980s. There was a trial, very, very popular trial that happened that actually in which a type 1 error was made. And in in that trial, the person who was actually innocent ended up going to jail and I think ended up in the jail for 20 years. And it was a really bad, just a bad use of statistics by somebody who did not understand statistics at all. And so, so remind me and I'll share that link with you. It's actually a TED talk about that trial. So, okay, so it, the only way to remember this is if you can remember this matrix here, and then the more problems you solve, the better you'll get at it. Now let's do the next problem, because it is also just like this previous problem. Somebody had asked me, how do we know we have the proportion or the mean as the parameter that we're testing? Here's an example. 3 years ago, the mean price of a single family home was 243,000. And a real estate broker believes that the mean price has increased since then. So my question to you first is, what is the population parameter that we're testing in this case? Sal, the matrix only involves the null hypothesis, right? If the null hypothesis is not true, then obviously the only other choice is alternative hypothesis. Yes, so we're now testing population mean. Very good. We're testing the mean now, not the proportion, but the mean. Excellent. And what is this a right tail, left tail, or a two-tail test? Again, it's a right tail test, right? Because we're talking about an increase. I wish they had an example of a left tail test in the first three problems, but they don't. So this is again an increase. So here are the null and the alternative hypotheses. The null hypothesis now does not involve P, it involves mu. Remember the mu is the sign for population mean. So it involves mu is equal to 240,000, and the alternative hypothesis is that mu is greater than 240,000. Okay. Now what is the type 1 error here? Remember again, the type 1 error is when the null hypothesis is actually true, but you find that you have to reject the null hypothesis. You find using your analysis that you're going to reject your null hypothesis. And by the way, I have not shown you the analysis we're going to do because we're going to start doing that from the next problem. So the broker rejects the hypothesis that the mean is 240,000 when it is in fact the true mean cost, right? If the mean is 240,000 and the broker rejects that it's 240,000 in favor of alternative hypothesis that it should be more than 240,000, that's an error, and that's a type 1 error. Okay. So again, just make sure you remember that type 1 error is when actually the null hypothesis is true, but your analysis says that you have to reject the null hypothesis. Which of the following is a type 2 error? The type 2 error is when the broker fails to reject the hypothesis that the mean price is this. So the broker actually says this is true, when in fact the real price is more than 240,000. Okay, that's a type 2 error. So again, this will come to you as you memorize this matrix, and just, in these two problems, you should be able to practice identifying type 1 and type 2 errors. Okay, now let's do this problem because actually this is also just a very simple problem. The next one maybe I think is where we do analysis, the actual analysis. Well, maybe not even this one. Number 6, not even this one. Number 7. So in number 7, we will do the entire hypothesis test, and that will prepare you for carrying out the analysis. Okay, problem number 4 has to do with choosing the correct conclusion. Okay, and why is that important? So can I close this? Is that okay? Okay, I've been asked to wait. Oh, I can close it. Okay, cool. All right. Okay, so in a hypothesis test, there will be 5 steps, and I'm not going to explain all of the steps until we go to problem 7. But here will be the steps. Step 1 will be identifying H0 and H1. Okay, so basically writing out your null and the alternative hypothesis. Very simple. You've seen what they are now, and you should be able to do it. Step 2 will be what is alpha? Alpha is called significance level. And don't worry about it. We're gonna, as we do problem 7, I will tell you what this is. Step 3, we will calculate what we call a test statistic. This test statistic will help us either reject or not reject the null hypothesis. So again, we will find out what this is. Step 4 will be find probability of this test statistic. So whatever test statistic you find, whatever value you find for this test statistic, what is the probability of getting that test statistic either or more or less, okay? what is the probability of getting that test statistic? If that probability is very, very small, then it will help us get to a, so it will help us make a conclusion about the null hypothesis. And again, we will do this when we go to problem 7. The step that we're doing in this problem right now is this step 5, when you have to make a conclusion. So I should probably say make a conclusion. So you should be able to do this. Actually, I'm going to use a different color. You should be able to use, you should be able to identify the null and the alternative hypothesis now, okay? And this is step 1. So you're okay with step 1. We're going to skip through these 3 steps. Now we're working on this make a conclusion step. So you should be okay with this too. So let's take a look at this. Suppose the null hypothesis is rejected, okay? So they're saying you've carried out the hypothesis test, and now suppose that you reject the null hypothesis, okay? State the conclusion based on the result of the test. 6 years ago, 11.2% of registered births were to teenage mothers. A sociologist believes that the percentage has decreased since then. So let me first ask you, can you please write out the null and the alternative hypotheses? And when you write this out, please write out H0 for null and H1 for alternative. And make sure to include what parameter are we testing, P or mu. Conrad, obviously right now we're not analyzing data, right? So these problems that we're doing right now, you'll have to do by yourself. And then problem 7 and on, all the hypothesis testing can be done in StackGraph. So what is the null and the alternative hypothesis? And if you can just write out the full hypothesis, that would be great. Very good. Brian, you missed a little bit, just a little piece there that Sandra has written there. P is equal to 0.112. Yes, very good. Okay, so okay, everyone is missing a little bit of, just a little bit of the concept here. So let me tell you what it should be. So here's the null hypothesis. This is the way you write it. H naught, identifying that we're writing the null hypothesis, is that P equals 0.112. Okay, this is the null hypothesis. H1 is that P1, P, what are they saying? They're saying a sociologist believes that the percentage has decreased since then. So the alternative is that P is less than 0.112. But Donna, they have to have P in both, right? You can't be testing proportion in the null and then mean in the alternative, right? It's like saying you're saying, is P equal to 0.112 or is P less than 0.112, right? That's the question you're asking. Is P equal to 0.112 or is P not equal to 0.112, right? That could be another test. So both null and alternative have to have the same parameter, okay? Because if this is not true, then you're going to say that this is true. This is the reason why you use the same parameter. So this is the hypothesis tests in this problem, the null and the alternative. Okay, this is the way you're going to write it. Okay. Okay. Now, remember the question said, suppose the null hypothesis is rejected. So you have found using your analysis that you reject the null hypothesis. Okay, so you have rejected the null hypothesis. Which of the following is the correct conclusion? Step 5, conclusion. Okay, so let me first read the right answer. The conclusion is that there is sufficient evidence, Okay, and this sufficient evidence comes from the analyzing the sample that you're going to analyze from problem 7 and on. There's sufficient evidence to conclude that the percentage of teenage mothers has decreased. Remember, you rejected the null hypothesis. You rejected this hypothesis in favor of this hypothesis. So in effect, you're saying that the proportion has decreased from 11.2%, right? Which is why this is the correct conclusion. There is sufficient evidence to conclude that the percentage of teenage mothers has decreased. Okay? Why is this not correct? There is not sufficient evidence to conclude that the percentage of teenage mothers has decreased. If there is not sufficient evidence that percentage of teenage mothers have decreased, well, then there's no reason to reject this null hypothesis, right? If there's not sufficient evidence to conclude that the proportion has decreased, well, then this you have to say then that this is correct, right? So tell me if this makes sense. Tell me if it makes sense that A is not the correct answer here. Okay, good. Let's look at C. There is not sufficient evidence to conclude that the percentage of teenage mothers has remained the same. Does that make sense? There is not sufficient evidence to conclude that the percentage has remained the same. Doesn't make sense. And yeah, but that's what it means. It means that it has changed, but we're not testing change. We're testing the alternative hypothesis is that P is less than 0.112. That probably would make sense if my alternative hypothesis was that P is not equal to 0.112, right? But that's not what we're testing. We are testing this. So we have to make a conclusion that it has decreased, right? That has to be a part of the conclusion statement, right? Well, there's not sufficient evidence that proportion has remained the same. So what that means is that the sociologist thinks that it has changed, right? If it has changed, it could have changed by being more than or less than. But we're testing a decrease. We're not testing more than, right? That's the reason why C is not correct. Does that make sense? Okay. Okay, and let's look at the last one. There is sufficient evidence to conclude that the percentage of teenage mothers has remained the same. Well, if there's sufficient evidence to conclude that percentage has remained the same, then we should not be rejecting the null hypothesis at all. But the question said that you in fact did reject the null hypothesis, right? So D is incorrect as well. Okay. Yes. So Sandra is right. If D was true, then we wouldn't be rejecting the null hypothesis. But the question said that you did your analysis and you rejected the null hypothesis. Okay. Done. Yes, Donna. These problems are going to be a little bit of a challenge. The first 6 problems, I would say for this module, the first 6 problems are harder than the rest of the problems because when you carry out this test, it makes a lot more sense than to go through, pieces by pieces and then start doing the problem. It makes a lot more sense when you actually do a problem. Okay, and I think hopefully we will do 1 or 2 7 problem 7 or problem 8 up to 7 or 8, and that will help you explain it. But this is the question said, suppose the null hypothesis is rejected. So what's the conclusion? The conclusion is that there's sufficient evidence to conclude that the percentage of teenage mothers has decreased. Okay, because if it has decreased, you would have rejected the null hypothesis. Okay. All right, let's take a look at this. Now you will help. You'll help with this problem. So suppose the null hypothesis is not rejected. 3 years ago, the mean price was 240,000. Real estate broker believes the mean price has increased. So my question to you is, can you type the null and the alternative hypotheses for this problem? Here's the problem again. And you don't have to type 243,716, just type 240 or something like that. It'll make sense. So I'm looking for the null and the alternative hypotheses. Okay, so you said null is that m equals this, and alternative is that m is greater than. Very, very good, Rob. That's right. Steve, not p. Remember, p is for proportions. Now we're talking about the mean. We're looking at the mean price of the single family home. So we have to use mu, and you can use m or u to say that you're using mu. Okay. Ryan, very good. Sandra, very, very good. Yes, that's right. Excellent, excellent. Looks like everyone has mastered the null and the alternative hypothesis. So just like everyone else said, mu is that it's equal to 240k, and alternative is that mu is greater than 240k. Of course, I'm writing 240k here when you should probably, you should definitely write 243,716. But just to save time, I'm just writing it this way. All right. So mu is that mu equals, the null hypothesis is that mu equals 240k, and the alternative is that mu is greater than 240k. All right. Very good. Now the problem said, suppose the null hypothesis is not rejected. So what is the conclusion? Okay, so this is the correct answer. There is not sufficient evidence. Okay, so whenever you reject, by the way, this is a hint. Whenever you reject the null hypothesis, like you did in the previous problem, the null hypothesis was rejected. You should automatically pick the words, there is sufficient evidence. Okay, these 4 words will appear. There is sufficient evidence to reject the null hypothesis. So whenever the null hypothesis is rejected, automatically think of there is sufficient evidence. Okay. In this problem, the null hypothesis is not rejected. So automatically you're just gonna add not in those 4 words. There is not sufficient evidence to conclude that the mean price of single family home has increased. Okay, meaning you're not rejecting the null hypothesis. Okay, does this make sense? Does it make sense why this is the correct answer? There's not sufficient evidence to conclude that the mean price has increased, meaning you're saying that you don't have evidence that this is true. There's no evidence that this is true. So obviously, you're not going to reject the null hypothesis. Okay? And then similarly, the rest of the options are not correct. These 2 are not correct because remember I said there is sufficient evidence are not the right words when the null hypothesis is rejected. When it's rejected, when it's not rejected. When the null hypothesis is not rejected, then you do not have sufficient evidence to reject. Okay? So these 2 are automatically wrong. If you can just master this, you can at least get from 4 options down to 2. Okay, and then it's just a matter of choosing the right one. Okay. All right, let's look at problem 6. Now problem 6 is funny, but this problem should not even be in this module, and the reason is you've already done this before. Determine the critical value for a right tail test regarding a population proportion where alpha is 0.1. Okay, this problem is, so this is, remember my step 2, I said I have to identify my alpha. Well, the problem will always give you alpha. Here's the alpha, 0.10. Let me tell you what that means. Level of significance. It said 0.10, okay? This is the level of significance. And in addition to this, the problem also said it's a right tail test. So my question to you is, if I draw a bell-shaped curve, and the problem says it's a right tail. So where's my tail? Is my tail on this side or this side? It's on the right. So it's here. Okay. So this is my rejection region. right here. Okay, now all this means the level of significance, which is alpha, is equal to 0.10, means that this probability under the curve, this highlighted probability or area under the curve is 0.10. That's all this means. And isn't this a problem that you've done before? That I'm giving you this area and you have to find the z value for this, right? You've done this before. You've done this for the last 2 weeks. So can you say yes if that's true? If you know exactly what to do here, right? We can use the normal calculator to find this. So let's find this. So we have to find the z such that this area is 0.10. So let's find it. Go to StatCrunch. For some reason it always blocks the first time I use it. I don't know why. Okay, and how do I do it? I'm going to go to Stat, Calculator, and I'm going to go to Normal. And here, all I have to do is change this sign to greater, change this to 0.10, which is what the question gave me, and I need my critical value here. And here it is. See, exactly the same area that I was looking for, right? Exactly the same area that I was looking for. This area under the curve is 0.10, and this critical value here is 1.2815. So this z is 1.28. Yes, Jessica, I was actually just going to ask that problem. So what if the question said that now let's do a few problems like this. So now let's say the question says, so how would we do this? So if I were to draw it, where is this rejection region? 0.05 left tail test. Okay, so the rejection region, as everyone else is saying, is on the left side. And what is the probability area under the curve? 0.05. Okay, and look at Vince. He has even computed the critical value, but the area under the curve is 0.05. So can I find this now? Can I find it here? Well, just like Jessica said, I'm going to put 0.05 here, but I'm going to change this sign to less than now because the tail is on the left side, and I get minus 1.645. So that's my z, this value here, minus 1.645. Very good. So are we okay with if I give you an alpha and I tell you where the tail is, if it's on the right or the left, you should be able to calculate the z critical value. Okay, good. Okay, but here's a trick question that I'm going to give you now. What if my alpha is 0.05, and now I have a two-tailed test? So it's not the right or the left tail, it's two-tailed test. So if I were to draw it, first of all, can you tell me where are my tails? Where are the tails? Just like Brian says, it's on the left, it's on the two sides, the left and the right side. Very good. Okay. Okay, very good. We just did the first step here. What is one of these areas equal to? Just one of them, not both, but just one. Wow, everyone's got it. Yep, 0.025. That's very, very good. it shows that you're thinking about this problem. Yes, it's 0.025. And this is also 0.025, right? I got point, well, my total is 0.05, right? You just divide it by 2 because these two halves are symmetric. So you divide it by 2 and you get 0.025, right? Each is 0.025. When you add them together, you get 0.05. Okay, very good. Now, isn't this a problem that you can do in StackCrunch? We've been doing this, right? This is 0.025. This is 0.025. This is 0.95, right? Yeah, you can just use the between. You can use this also, but you can use between. And the between area limit, as I said, is 0.95, right? In the middle is 0.95. So I can just put 0.95 here. And here are the critical values. It's minus 1.96 and 1.96. So this is 1.96. This is minus 1.96, right? It's okay. That's because the total probability is what? Total probability is, yep, is 1, right? Probabilities must sum to 1. So here you have 0.025, 0.025. This together is 0.05, right? And in order for the area to sum to 1, the middle part has to be 0.95. Because when you have 0.95, you add it to this 0.05, you get 1. Okay? In other words, the central region is simply 1 minus 0.05, right? It's 0.95. Okay, very good. And now you just found your critical values. So now you should be able to find your critical values for the left-tailed, right-tailed test, left-tailed test, and two-tailed test. This should be very simple now. Every problem will give you alpha. You will never have to calculate alpha. Okay? You will always be given alpha. Sandra, you'll see why. Okay? We'll see why we have to calculate the critical values. Okay? Why the critical values are different? I'm not sure if I understand that question. You mean like why is it this different than this? Okay. Yeah, I mean these are different, right? Because it's a two-tailed test, right? So you have a critical value on the right side, critical value on the left side, and then these are the values. What you're going to do is when we do these problems, you're going to find your test statistic from your sample and you're going to compare it to these critical values. And you're going to try to understand if the value that you found, does it lie in this rejection region or not? And if it does or not, then you make your conclusions. We're going to do that. But every problem will give you this alpha. Okay, so you don't have to calculate it. You just have to know where the regions are. And you have to find a way to calculate critical values. Okay, good. All right, let's go to the next problem, which is the actual test. So this is where it really starts. So I'm going to clean this and I'm going to go through step by step. I do these problems using these steps. And I think this is a nice way to do it because if you do it step by step, you always sort of get the right answer. Test the hypothesis using classical approach and the p-value approach. So I'm going to tell you what those are. But the null hypothesis is that p is 0.5. Alternative is that p is less than 0.5. So the null is that p is 0.5. Alternative is that p is less than 5. Okay, so what is the population parameter that we're testing here? Population proportion. Very good. Okay, so is this step clear? Are we all okay with this step reading from the problem? Okay, the problem gave you the step, right? So you just have to say step 1 is this. Okay, very good. Remember, step 2 was that I need to find my alpha. So let's see, is the alpha given here? Is the alpha given here? And if yes, what is the value? 0.10. It's given right here. Alpha is 0.10. Okay, now let me ask you, looking at the alternative hypothesis, and here's the alpha, how would I draw my distribution? Where is the rejection region? It's a left tail, so the rejection region is on the left side. And what is the probability of this rejection region or area under the curve? What is that? Very good, 0.10. Okay. Okay, excellent. Okay, so step 2 is done. Okay, now we're going to do step 3. And step 3 is something new now for you. Remember, step 3 was that I need to find my test statistic. First, I'm going to show you how to do this manually, and then I'll show you how to do this in StatCrunch. And obviously, you're going to like the manual method or the StatCrunch method more. Okay. The way you do this test statistic is this way. First, you have to find your p hat. P hat is the proportion from the sample. What is the proportion from the sample? So this is the sample proportion, not the population proportion, which is p. This is the sample-based proportion. So what is this equal to? Well, it's simply equal to x over n. And this is given in the problem, right? It says x is 66 and n is 150. What that means is the sample size is 150. So out of 150 observations or individuals, 66 have the specified characteristic that you're studying. That's what that means. So the proportion is 66 divided by 150. So what is that equal to? Let's just calculate that. Oh, it's 0.44. Okay, Donna did it for me, so I'm gonna just write the value here. It's 0.44. Okay, so we just found our p hat. Now we're gonna find our test statistic. I'll just write TS. Test statistic is equal to this formula now. Okay, so try to follow this. It's a little bit, involves a little bit of work, but it's easy. P hat minus P based on H naught. Okay, P that is given in your H naught. So let me just write that. Instead of writing P H naught, I'm just going to write this as P0. Okay? P0 means that this P is based on the null hypothesis, which is 0.50. So P hat minus P naught divided by square root, I don't want to take too much space, so square root of P naught 1 minus P naught divided by n. Okay, this square root is for the whole thing. Okay, so a little bit of it involves a little bit of calculation, but let me write the values and then it'll make much more sense. Okay, so what is p hat? What is p hat here? 0.44. What is p naught? What is p naught in the problem? Is this p under the null hypothesis is 0.50. Okay. Okay, now I'm going to write down the denominator. In the denominator, we again have p naught, so which is 0.50, multiplied by 1 minus p naught, so that's 1 minus 0.50, whole thing divided by n, and n is given in the problem as 150. So this, now tell me, do you all agree that I can calculate this? Do you all agree I can get to a value here, right? It's just arithmetic now. All I have to do is just, find the numerator, denominator, divide them, and then get the answer, right? So this is how you calculate the test statistic. Now let me show you how you can do this in StatCrunch. And StatCrunch does exactly this calculation. Okay, and now you're really gonna start liking StatCrunch. So here's the way to do this problem in StatCrunch. You're gonna go to Stat, and you're gonna go to Proportion Stats. Okay, because again we're working with proportions. You're gonna go to one sample and with summary. Okay, this is exactly the same thing we did last week. And again, this is very easy. Number of successes is 66. That's your X out of a total of 150 observations. Remember last week we were selecting this option, confidence intervals for P. Well, this week we're gonna just go with hypothesis test. We're gonna test the hypothesis. And look what it's asking. It's saying, what is your P equal to? Well, in the problem, the P is 0.50, so I don't need to change this. I keep this as 0.50. But what do I have to change here? What do I have to change here in this hypothesis test? Not the symbol. Oh, you mean this symbol, Maya. Yes, you're right. Yes, we're going to change this symbol because it's given as not equal. We have to choose the right one. And you can see that we have the three options that we need. So which one are we choosing? Less than. I choose less than. And that's it. That is all I have to do. Hit compute and take a look at this. You see this Z-stat? This is your test statistic. This is the test statistic that I would have calculated if I did this arithmetic here. Okay, it's given right here, minus 1.4696. So this answer here would be minus 1.4696. That's your test statistic. Yes, sometimes you'll see H1, sometimes you'll see HA. It's the same thing. It's alternative hypothesis. Okay, H1 and HA are the same thing. Good question, Sandra. So this is your Z stat, the test statistic, minus 1.4696. Okay, and this here is the p-value, and let's write it down. It's 0.0708. So the p-value is, that was going to be your step 4, and step 4, the p-value is 0.0708. Okay. Okay. Now this is going to be a little tricky. So what I'm going to do now is, the question said it wanted you to do the analysis using classical approach and the p-value approach. Okay, so let me first talk about the p-value approach. You have found everything. You found your test statistic. You found your p-value. This is all you need to carry out the test. Okay. Now you have to get to step 5. Step 5 was conclusion, to make your conclusion. And here is how you're going to make the conclusion. I wish I had another slide for this because it's going to take a little bit of area, but let me do this. The p-value came from the output. See this? The p-value is 0.0708. Is given right in front of the test statistic. Okay, I can show you how to calculate this. It's very easy. I'll show you how to calculate it. All right, here's how you're going to do it. The p-value approach. P-value approach. If p-value is less than alpha, then you reject the null hypothesis. Otherwise, do not reject the null hypothesis. Okay, let me repeat again. If this p-value that you found using StatCrunch is less than the alpha that is given in the problem, then you reject the null hypothesis. So tell me if that makes sense. It's a very simple rule. This rule you have to remember. Very simple rule. If the p-value that you calculated is less than alpha, reject the null hypothesis. Otherwise, do not reject the null hypothesis. Now, what does it mean? Why do we do this? Here's the reason. This 10% alpha, this rejection region, this 10%, what it does is it signifies, what is the likelihood of you, okay, of having or calculating a value where your null hypothesis cannot be rejected. So if you were to find the value right at this point, right at that point, then you're at the edge of either rejecting or not rejecting the null hypothesis, right? This p-value is less than alpha, is 0.0708. Can you tell me, oops, hold on. It's 0.0708. Do you think that this 0.0708, if I highlight here, do you think it would go all the way till this side, or would it remain in the rejection region? If I were to highlight 0.0708 under this, in this region, which is 0.10, 0.10, do you think I would overflow into this not rejection region, or would I remain in the rejection region? I would remain in here, right? Because 0708 is less than 0.10. So you can see that I'm going to probably highlight this area, right? This is the reason why. So where am I falling? I'm falling in the rejection region. Remember I said if you're in the rejection region, you always reject the null hypothesis. This is the reason why if the p-value is less than alpha, you reject the null hypothesis, okay? This is the explanation for this rule. If it's not less than alpha, so if it's more than alpha, even if it's equal or more, you do not reject the null. So if you had found, say you had found that your p-value was 0.1708, 1708 is more than 0.10. So obviously you would be highlighting, area probably until here somewhere, right? It would have to be more than 0.10. So now you're not in the rejection region. Now you're coming in this non-rejection region. So you will not be able to reject the null hypothesis. That's the reason for this, okay? So my question to you now is, based on this rule, what is my conclusion? Based on this rule here, what is the conclusion that I will make? Very good. I just reject the null hypothesis. So remember those problems where we had to write the statement for conclusion? We're going to say, first of all, I'm going to say reject H naught. And then the full statement will be, there is sufficient evidence that your proportion is less than 0.50. Remember those conclusions in the problems before? That is exactly how we're going to conclude this test. Once you get to this decision, you've done your test. Okay. So your conclusion will be just like you did in the previous problems. Okay, this is a good example. Remember, we're rejecting the null hypothesis. Remember, in this problem we said that the null hypothesis is rejected. And so what did you say? You said there is sufficient evidence to conclude that the percentage of teenage mothers has decreased. This was your alternative hypothesis. In this case, you're going to say there is sufficient evidence to conclude that your proportion, whatever proportion you're studying, is less than 0.50. Okay? That's your conclusion based on the test. Yeah, yeah. I mean, you came to the conclusion based on this p-value approach. You compared the p-value against alpha. It was less than alpha. You said reject the null hypothesis. Okay? That is going to remain the same. P-value approach will always be this. For every test that you do, you're going to find your p-value and the test statistic. And then you can use the p-value to get to the conclusion. Okay. Yeah, let me get to the classical approach now. I want to make sure the p-value approach is clear. Yes, Jessica, that's right. Remember here I said otherwise do not reject, right? If the p-value is less than alpha, reject the null hypothesis. Otherwise, do not reject the null hypothesis. So the p-value has to be less than alpha to reject the null hypothesis. Otherwise, you will not reject the null hypothesis. Is this clear? Is this piece clear? And now I can talk about the classical approach. Okay. Okay, so I'm going to talk about the classical approach in this region as well. So I'm going to erase this, okay? All right, now we go to the classical approach. And let me warn you, I personally like the p-value approach because it's very easy to follow. It's just a rule that you have to remember. Is your p-value less than alpha? If yes, reject the null hypothesis. If not, do not reject the null hypothesis. Is that easy to remember? Classical approach involves a little bit of work, okay? And so here's how we're going to do it. The first thing you have to do in the classical approach is find your critical value. Critical value. So in this case, your critical value is this value here, and we had found this in the previous problem. So I'm going to find z critical. How do we find this? Remember we said is 0.10, so I can just use the calculator, the normal calculator, to find 0.10. And remember I said that this is your critical value, minus 1.28. Okay, this is the critical value. This is the way to find it. Alpha is 0.10. It's a left tail test. So my critical value is minus 1.28. So ZC is 1 minus 1.28. Okay. Okay, now I want you to focus on this region. I'm gonna magnify it a little bit. Okay. So I'm gonna magnify this region right here. So let me magnify this piece. So it looks something like this. And this is my rejection region. If this is the rejection region, which is 0.10, I found that my critical value is minus 1.28. So this value is minus 1.28. Okay. So my question to you is, my test statistic that I found was minus 1.4696. Where does this value lie? Is it going to be on this side in the rejection region, or is it going to be on the right side of minus 1.28? Where will this value be? Minus 1.4696. Okay, now be careful because this is negative. We're talking about negative values. It's going to be on the left side, right? So do you all agree that this value, test statistic, will fall in the rejection region? Maybe somewhere here. Do you all agree with that? Yep, so that's all you have to test. The rule here is your test statistic in rejection region? This is the question you have to ask. Is your test statistic that you calculated in the rejection region? If yes, reject the null hypothesis. If not, do not reject the null hypothesis. So in this case, is your test statistic in rejection region? Yes. So reject the null hypothesis. So using the p-value or the classical approach, you always get the same answer. You should never ever get two different answers, okay? Both approaches will give you the same answer. Now, I personally prefer, if the question doesn't ask you specifically, I prefer going with the p-value approach because it's simpler. All you have to do is calculate your p-value, compare it to alpha. If it's less than alpha, reject the null hypothesis. That's all you have to do. In this classical approach, you have this added step. You have to find your critical value. And that is the step that you need to do more calculations. And then you have to find, the you have to get to your conclusion. Okay, so all right, I'll show you again how I did it. This is just like I did the previous problem. I went to stat, calculators, normal. I have a left tail test, so I choose the left less than sign, and my alpha is 0.10. So I put 0.10. And here is the critical value. It's minus 1.281. This is how I calculated the critical value. Okay. Yes, Jessica, that's right. So you should not have a case where p-value approach says reject and the classical approach says do not reject. That's never going to happen. And vice versa. You will always, always, always get the same conclusion using both the approaches. How do you know when you're getting into the non-rejection region? Well, I mean, what if, okay, let me answer that question. You see this Z critical is minus 1.28, right? What if your test statistic that you calculated here, what if this value was say minus 0.50? What if let me give a more realistic number. Say that you found your test statistic was minus 0.571. Okay, where would minus 0.571 be? Would it be on the left side of this minus 1.28 or on the right side of this? It would be on the right side of it, right? It would be in this direction, in that direction, right? Well, then you're not in the rejection region anymore, right, Sylvia? Would you agree that you're not in the rejection region if you're on the right side of minus 1.28? Right? That's how then you are in the non-rejection region, and therefore you will not reject the null hypothesis. You see, that's why I personally think this approach is a little confusing because you have to know, you have to draw it out, and you have to know where, what side you're on. Are you on the rejection region side or non-rejection region side? This is a simpler approach. P-value approach is just comparing your p-value to alpha. Alpha is always given in the problem, so there's no additional steps for calculation. Just get your p-value, compare to alpha, get the conclusion. Even if the problem says use classical approach, I would say use the p-value approach to at least get the correct conclusion so that you don't make a mistake here. Negative is not the rejection region. No, so I think there's a little bit of confusion. So maybe what I'm going to do is I'm going to erase this. Okay, so in this problem, my critical value was minus 1.28. And we found my test statistic, test stat, was minus 1.46. Okay. So, and obviously this way the numbers are increasing. So, so Sylvia, my question to you is, where would minus 1.46 be? Would it be on this side or on this side? This is your critical value. So would it be on the left side of critical value or on the right side of critical value? No, it wouldn't be on the right, right? This is less than minus 1.28, right? minus 1.46 is less than minus 1.28. It's the minus sign, right? We're talking about negative signs, right? So 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 this would be less than minus 1.28. So it would be somewhere here, right? That might be the confusion, right? Maybe you thought it should be greater than, but it's actually less than, right? Well, what if your test statistic, say for example, it was minus 0.571, right? Where would minus 0.571 be? On the right side or on the left side? It would be on the right side here somewhere, right? It would be here. In this case, you're not in the rejection region. You're in the non-rejection region. So you do not reject. So if you have this case, you reject H naught. If you have this case, you do not reject H naught. And this is the confusion that I do not like about this classical approach. P-value approach is much simpler. Okay, alpha is 0.10. If you look at your output here, p-value is given. When you do your problem, StatCrunch will print out your p-value, 0.0708. And then now all you have to do is compare these two. That's all. Compare p-value against alpha. If it's less, reject H naught. So p-value is in fact less than alpha here, so you reject H naught. So don't you think this is a simpler approach than the classical approach? Don't you all think that's true? Yeah, it's much simpler. I personally think it's simpler too. Okay, so what we're going to do is we're going to stop here. Okay, this module will require some practice. So my suggestion to you is before Thursday, please go through these problems that we've done so far. Okay, try to do them um, in MyStatLab so that you get some practice. And we'll start with problem 8 and on Thursday. Oh yeah, let me point you to that. It's a very, very interesting TED Talk. Okay, so there it is. Now, it's a 20-minute talk. So in the first few minutes, he's gonna tell you the basics about statistics that were used, and then he will explain the situation that actually occurred. Okay. You might have, yes, because it was a big, I mean, this is pretty much an example they use in all of the law courses. It's the trial of Sally Clark. It's very interesting. So take a look at it, and I'll ask you about it. If you see it in the next day or two, I'll ask you on Thursday what do you think. All right, so we're done for tonight. I'll stop the recording. We'll start on Wednesday.